Lesson 79, metric volume and 40, 40, 45, 45, 90-degree triangles. All right, let's talk about metric volume first. Just a few things to mention. Talking about different metric units for defining volume. One of the most common metric units for volume is the liter. All right, a liter is equal to 1,000 cubic centimeters. All right, so a liter is equal to 1,000 cubic centimeters. All right, a cubic centimeter is equal to 1 milliliter. All right, so if a cubic centimeter is equal to 1 milliliter, that would mean that 1,000 cubic centimeters are equal to 1,000 milliliters, which then in turn means a liter is equal to 1,000 milliliters. All right, so we're just going to use that information to do conversions. All right, so let's just work our way through a few examples. All right, the first example, we want to convert 14,000 milliliters to liters. All right, so we're converting using, we're going to go ahead and use unit multipliers. When using a unit multiplier, we want to cross-cancel the unit that we are getting rid of and put the unit that we are looking to on the top. All right, so we put milliliters on the bottom so that we can cross-cancel it, and liters goes on the top. Now we just need to fill in our information. Now from the information that we just wrote down above, we know that 1,000 milliliters is equal to 1 liter. All right, so our milliliters units can cancel out, but also our numbers can cross-cancel, and we're left with 14 liters. All right, so this should be review, hopefully, but we're just doing some different conversions. All right. The next one we're going to do is a little more complicated. All right, we're going to convert 4 feet cubed, or cubic feet. We're going to convert it to liters. All right, now, we have to remember we are starting in the English system with feet. We want to go to metric volume. Okay, so we know that we can convert from inches to centimeters. That is our conversion that we use between the English system and the metric system. But once we get to centimeters, we then need to convert centimeters to our liters. All right, so let's start with 4 cubic feet. Now this is 4 feet, 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 since it's cubed, so we're actually going to be doing 3 unit multipliers. All right, so when I get rid of feet, feet goes on the bottom, I'm going to go feet to inches. Okay, and make sure that we do this 3 times. All right, and let's fill in our numbers. There are 12 inches per 1 foot. All right, now that our feet units are canceled out, we want to go from inches to centimeters. Now, inches is going to go on the bottom because we want to cancel it out. And we know that the rate, or hopefully we can look back in our notes because it's written there, our conversion rate from inches to centimeters is that there are 2.54 centimeters per 1 inch. Okay, here's where it gets a little tricky. We want to go from cubic centimeters to liters. Now, we need to remember that 1,000 cubic centimeters is the same thing as 1,000 milliliters. So actually, since I have centimeters cubed, all 3 of these units are going to cross-cancel with 1 unit of milliliters because 1,000 centimeters cubed is equal to 1,000 milliliters. All right, so 3 units of centimeters is equal to 1 unit of milliliters. So all 3 of these centimeters are going to cancel out with my 1 unit of milliliters. All right, and then we are using milliliters to convert to liters. All right, so then we're just going to fill in our numbers. There are 1,000 milliliters per 1 liter. Okay, so now that all of our units are canceled, we just multiply the numbers. And you can leave these as a multiplication problem instead of multiplying them out. So what I would do is 4 times 12 cubed times 2.54 cubed divided by 1,000 liters. And that's how I would leave my answer. Okay. All right, I'm going to leave you one to do by yourself. I want you to try this on your own tonight. All right, the example looks like this. We're converting 4.7 liters, and we're going to convert it back to cubic inches. All right, so we're actually doing this one backwards from the one that we just did. All right, so I want you to go ahead and try that one on your own tonight. Go ahead and pause the video, and when you've completed that problem, hit play to continue. All right, the next thing we're going to talk about is the 40, 40, 45, 45, 90 triangle. All right, this is just another reference triangle. A few lessons back, we talked about a 30, 60, 90 degree triangle. We talked about reference triangles for that triangle. Now we're doing a 40, 40, 45, 45, 90 triangle and doing a reference triangle for that. So, okay, we know, again, it's a right triangle, but both angles are 45 degrees instead of one being 30 and one being 60. This is just another triangle to refer back to when we're working with similar triangles. All right, the reference triangle for my 45, 45, 90 is a little simpler than my 30, 60, 90. Both sides are 1 and the hypotenuse is root 2. All right, so both sides are the same because both angles are the same. Both angles are 45. My hypotenuse is 2, or root 2. All right. So we're going to use this reference triangle to solve for missing sides in similar triangles. All right, so we're going to do one example together, and then, of course, you get to do one by yourself. All right, so we are going to use this reference triangle to solve for missing sides in our triangle XY7. All right, both of these angles are 45 degrees, and we're going to refer back to this reference triangle over here to solve for missing sides here. All right, we do that by setting up proportions and comparing sides. All right, so we're going to compare side x to 1. So x is to 1 as y is to 1, meaning that x and y are going to be the same. Okay, so x is to 1 as y is to 1 as 7 is to root 2. All right, so we're just going to cross multiply and divide to solve. All right, I'm going to use this proportion. I'm going to cross multiply root 2y and 7 times 1. All right, to get y by itself, I divide by the square root of 2. Now, keep in mind, we cannot have square roots in the denominator. All right, so we're going to multiply through by the square root of 2. And I get 7 root 2 over 2. Okay, so y is equal to 7 root 2 over 2. And we mentioned previously that x was equal to y, so x is also equal to 7 root 2 over 2. Okay? All right, I want you to do one more, just using that 45, 45, 90 triangle to solve for missing sides. All right, in this triangle, we're solving for sides y and for side z. Okay, notice one is the hypotenuse and one is the side, so they're not going to be the same. All right, so you're going to use a 40, 40, 45, 45, 90 triangle to solve for missing sides for that triangle. Go ahead and work that on your own, and we will check it when we come into class.